Okay. So let's look at chapter 4, section 2. Graphing polynomials. All right. To graph a polynomial, we need the following: the degree, A, the shape and direction of the graph, the x-intercepts, the y-intercepts, sept is singular, and some other points. Because we're going to know what it looks like. What we're not going to know is all the points. So we have to figure out some points to know the basic shape. We have to plug the dots in so we know what we're looking at. Let's begin with example 1. Actually, let's look at these. So we have two terms. It's a binomial, so when we have two terms and they both have x's, factor out what we can. -2 and 3 have nothing in common, but they both have how many x's? They both have at least 3. So we take that out, which leaves us with, I took away 3 from there, so I only have 1 left. I took all of those. So I set them all equal to 0. It's a monomial, so x is equal to 0. And -2x plus 3 equals 0. I set that equals 0. Which is 3 equals 2x. I'll just move that one over since it's negative. So x is equal to 3 divided by 2. X equals 0 and x equals 3 over 2 are called our critical points or critical values in calculus. What it tells us is this: since these are my x-intercepts, if we look at the graph, so our x-intercept is at 0, and our another x-intercept is at 1 1/2. Those are my x-intercepts. We have to know what happens on this side between there and those. That's why they call those the critical values. Because we know exactly what happens there. There are zeros. So what we're looking for here is from negative infinity to 0, what happens? Then we will look at the next set. From 0 to 3/2, what happens? And then from 3/2 to positive infinity, what happens there? Okay. The way the book wants you to do this is very, it takes time consuming. Because what they want you to do now is take a value on this side, any value, let's say -1. That's my test value. On this side, take 1. On this interval. And on this interval, let's take another one. Let's take 2. And what it's telling you to do is plug those values into the original equation and just see what the sign's going to be. If it's positive, that means on this side of the graph, it'll be up here. If it's negative, it'll be down here on this interval. If it's positive, it'll be up here. If it's negative, it's down here. And likewise with the last interval. That's all it wants you to do. But we already know what's going to happen. We already know what's going to happen. We know the x-intercepts. A is less than 0. It's -2. N is 4. So since N is 4, they both point the same direction. Since it's negative, they're both going to point down. So we know the graph is going to look like this. So what I'm predicting, at -1, we're going to have a negative answer. And at 2, we're going to have a negative answer. So let's see here. So at -1, we have -2, -1 to the 4th, plus 3, -1 to the 3rd. I'm taking this value, plugging it into my original equation, and it wants to know, I'm predicting this one's going to be negative, this one's going to be negative. So -1 to the 4th is positive, so it's +1. So we have -2. -1 to an odd power is negative, so positive times negative is negative. It'll be -5. It's negative. That means it's below the x-axis. Likewise at 2. We have -2, 2 to the 4th, plus 3, 2 to the 3rd. 2 to the 4th, 2, 4, 8 is 16. 2 to the 3rd is 8. 16 times -2 is -32. 3 times 8 is 24. It's going to be -8. So it's going to be below the x-axis. We knew that already. Since we factored these out, look at the multiplicities. They're both odd, so the graph is going to cross there. So the graph's going to look something like this. That means at 1, we're going to get a positive answer. -2 times 1 to the 4th. 3 times 1 to the 3rd. 1 to the 4th is 1, so I have -2 plus 3 is 1. It's positive, so it's above the x-axis. Duh, we figured that out. So once you factor them out, once we factor these out, look at the exponents, that tells you the multiplicities. We know if it's gonna be above or below. Okay. Example 2. Graph the polynomial. It's grouping, because there's a minus sign there, I have to include that. So what do they both have in common? X squared. So I took out 2 x's, I have 1 left there. I took out 2 x's, so it's just a coefficient. There's a coefficient there. I take out the negative. 8 and 4 both have a 4 in common. Since I took out the negative, I got to change both of those signs. They're both going to be positive. So negative, negative makes it positive. 8 divided by 4 is 2x. Negative, negative makes it a positive 1. The coefficients get their own parenthesis. And since these two are the same, they stay together. And both of the exponents are 1. So at those x-intercepts, they're going to cross. So we have x squared minus 4 equals 0. 2x plus 1 equals 0. Add 4. Subtract 1. Square root. X equals plus or minus 2. X equals negative 1/2. 5 by 2. So these are my 3 answers. Since it's we know our y-intercept is at negative 4. At positive and negative 2. And at negative 1/2. A equals 2, so it's greater than 0. N equals 3, so it's odd. So the graph looks like this. So the left side, from the left dot, it goes down. From the right dot, it goes up. Since their exponents are 1, they cross. So it crosses there, and it crosses there, and it crosses there. So there's the basic shape of it. Again, we have to plot some real points and see what we get. So what we look at here is the first is from negative infinity to negative 2. From negative 2 to negative 1/2. From negative 1/2 to 2. And from 2 to infinity. Those are the x values. Negative infinity to negative 2, negative 2 to negative 1/2, negative 1/2 to 2. So that's what those say. Pick a value in this open domain. So I pick negative 3. I pick negative 1. You can pick 0, pick 0. And then I pick 3. So at this interval, we know it's already down here, so we know it's gonna be negative. I'm saying this one here is gonna be positive because it's over here. Between this, it's above there, so it's gonna be positive, and from it's gonna be negative. So work those out, you'll see. So this is below the x-axis, above the x-axis, below and above. Negative, positive, negative, positive. That's all it's telling us. So our x-intercepts are at -1, +2, and +4. And our y-intercept is at -16. So at -1, 2, and 4. We know a equals 1, so it's greater than 0. N is 4, so it's even. So both directions, they both point up. So at the endpoints, our graph will look something like this. It's going up. At -1, it's this odd exponent, it's going to cross. At 2, it's even, so it's got to cross through there. So it's just going to bounce off that x, because at 2, it's an even exponent. At 4, it's odd, so it's going to cross. So there we have it. That's what the graph looks like. So yeah, what we would look at here is from -infinity to -1, from -1 to 2, from 2 to 4, and then from 4 to infinity. Pick a test value. That's not that point. So it's -2. You can use 0, use 0, 3, and 5. Again, plug those into the function. And you get a value. And here it's either going to be positive or negative. Since on this side we know it's going to be above there, it's above the x-axis. At 0, it'll be negative because we know it's going to be below the x-axis. At 3, it's also below the x-axis. And at 4, it's going to be positive, it's above the x-axis. So that's what it tells. It pretty much gives us a roadmap of how we're going to go. You just have to know how to use it in case the homework assignments ask you to plug in the numbers. So you have to -2, plug it. I plug it into here. -2 plus 1 is -1. -2 minus 4 is -6. So -6 times -1 is 6. -2 minus 2 is -4 squared is 16. It should be all positive. So duh, it's positive. And do the same thing for all of them. So that's how you graph polynomials. There's a theorem that we deal with called the intermediate value theorem. Pretty much what this thing says is if I have a function and you give me two values in a domain, if I plug those endpoints, f of A and f of B in there, and if they come out with numbers, the answers that are different signs, that means there has to be a number between there, let's say call it C, where f of C is equal to 0, where it crosses the x-axis. So if you have a positive number here and negative number here, there has to be, and they're connected, there has to be some point in there where it equals 0. Again, the way you do it is just take the endpoints from your domain, plug them in there. If they're opposite signs, then you'll have at least one x-intercept. If they're both the same signs, you can't tell me anything about it yet. So let's look at these. F of x equals this. What's saying here is from -4 to -2. So we do -4, plug it in there. So it's -4 cubed plus -4 squared minus 6 times -4. Negative in a cube, it's negative. 4 to the third power is 4 times 4 is 16. 16 times 4 is 64. Negative in the even power, so it's going to be positive. 4 squared is 16. Negative times negative is positive. 6 times 4 is 24. So -64 plus 40 is -24. So f at -4 is 24. Now we do it at -2. F of -2. -2 cubed plus -2 squared minus 6 times -2. Negative to an odd power is negative. 2 cubed, 2 times 2 times 2 is 8. 2 squared is 4. Negative negative is a positive. 6 times 2 is 12. -8 plus 16 is +8. So they have opposite signs. So it's going to have at least 1 0 between -4 and -2. There'll be 1 0, at least 1 0. So between x equals -4 and x equals -2, there will be at least 1 x-intercept. Okay, same equation, but not different endpoints. We look at -1, and we look at 3. So we have -1 cubed plus -1 squared minus 6 times -1. 3 cubed plus 3 squared minus 6 times 3. -1 cubed is -1. -1 squared is 1. Negative, negative is positive 6. So this is a positive 6 at negative 1. 3 times 3 is 9 times 3 is 27 plus 9 minus 18. 27 plus 9 is 36 minus 18 is 18. They're both positive, so no conclusion. It may, but we're not sure, not for certain. For certain, not for certain. Because what if the graph was like this? At negative 2 and 2. They give you the same value, but it does cross, even though the test would be wrong. So do the rest of them, you get the same thing. All right, so that's section 2. Let's stop this so we can start section 3.